Hello and welcome back to part 2. In part 1, I forgot a few steps, so we'll go ahead and cover that really quickly. Now, the first thing we want to do is select the camera and search for auto possess. It'll be disabled. We want to set that to player 0. Otherwise, this camera won't be used. Another thing we need to do is we need to go back to project settings, go to maps and modes, and where it says default game mode, we need to select the game mode that we made. So that would be Tetris game mode. Go ahead and exit that. And one other thing we can do, a little trick I can show you. So go ahead and select all of the sprites that you made. Right click, look for asset actions, and then bulk edit via property matrix. And before you edit everything, make sure you have everything selected. And now what we want to do is go down to collision. Make sure we have use 3D physics. We're going to want that for later on. Okay, so what you want to do is under collision, go all the way to the bottom where it says collision thickness and set this to be 1. And then with everything selected, go ahead and save all. So now that we've done that, we can go back to the game and we can press play and you'll see everything is there, everything's working so far. So we'll go ahead and we'll make another actor. And this is going to be what runs the game. I'm going to call it Tetris player. So we'll go ahead and open this up. We'll go ahead and leave everything for right now. We'll go to the event graph. Go ahead and delete everything. We're not going to need it. So how this is going to work is that there's going to be an array of booleans. And that's basically going to drive everything. We're going to go ahead and set it up. So what we want to do first is let's go ahead and create a variable. And I'm going to call it grid data. And we're going to want to make this an array. Go ahead and compile. And then we're going to go ahead and make a quick function. I'm going to call it setup. Now really quickly, we're going to have columns and rows. Now, I could be wrong, but I've always considered a column to go from the left to the right, and then rows to go from the top to the bottom. And we're going to populate this array. So there's 9, or actually 10. There's 10 rows here, and there's 21 columns. I already know this because I counted it. But that's how we're going to make we're going to make a loop that's going to run through and populate this array. Or you could go ahead and add, I believe it's 220 entries. But we can't do that. That's too much work. So what we're going to do is make a loop, not a for each loop, just a regular loop. And we're going to set the first index to 0 and then the second one to 21. And just so we know what this is, I'm going to set this to be a column, or name it column, just so we don't lose track. Like I said, I've considered columns to be, I consider this to be a column and these rows. I could be doing this backwards. I'm not sure. I probably am doing it backwards, but we'll keep going anyway. You can always switch this to row if you'd like. And so the next one we're going to make is another for loop. So we're going to set this to be 0 and 9. And we'll go ahead and comment this to as a row. So what's happening here? Well, first, before I explain it, let's go ahead and we'll just do an add. And it'll just default to false. So make sure your array is empty. So now when we run the game, it's going to populate each column and each row with a boolean. And if we do like a print string and then get the length of it, we can go ahead, press play, and I forgot to call the function. So we'll go back to begin play. I said we didn't need it, but you can hold down P and left click and it'll spawn a node. So we'll go ahead and plug that in really quickly, and we can check. It should be 220. And I also forgot to put this in the scene. So we press play, Yep, 220, so everything's working just right. I'll go ahead and remove this. Now, we want to go ahead and duplicate this. So I'm just going to call this clear. Now, what we're doing is this is so when we go to clean, when there's a full line, we're going to go ahead and set this back to everything to be false, and then each block piece that's in the grid will repopulate it. And we'll go into more detail when we get to that section. But for right now, let's go ahead and have this ready. So that way we don't have to come back and re-add it. Set it to that. So grid data. So the clear grid data is going to match whatever the grid data is. And that's that way we don't have to do this loop again. And we should go ahead and set this to be private because nothing else needs to access it. Now that we have that, let's go back really quickly and let us go ahead and make a custom event called start game. Now what this is going to do for right now, we'll go ahead and we'll call it on begin play. But this is basically, we're going to have an animation play, and we don't want the game to start until after the animation has finished. So we'll set this up. Now, so after you've made a custom event called start game and then plugged into begin play for right now, we're going to go ahead and now we have this large array of 220 indexes. Now, how do we access it? Basically, how do we get? So we want to access this particular column and row. I'm not sure what it is. I'm not going to count it, but how do we get to it? And you might think we could just do a for loop on it, go through it until we find what we're looking for, basically. And you could do that, but that's a huge performance loss. So what we're going to do is we're going to create another function. So go ahead and name this grid position to index. And really quickly, how this is going to work is we're going to need to know the column and the row we're on. So two variables. Now I'm going to make a new folder really quickly called blocks. And we're going to add a struct in here. Or we're also going to add the block blueprint class, but we'll do that later. So right now, right click, go to blueprints, struct, and we're going to call this piece point. So at the end, I'm going to put st for struct. So we'll go ahead, we'll add an integer. So we'll go ahead and we'll add two integers to it. The first one we're going to call is row. The second one is going to be column. So we're going to put X in the tooltip so that way we know what it is. We don't get lost. And what I mean by get lost is in case we get the row and column mixed up, we can just think the row is on the x-axis and the column will be on y. So we'll go ahead and put y in the tooltip. We'll go ahead and save that. And now when we come in here, let's go ahead and add that as an input. And so we'll name the input point. And then let's go ahead and give it a return node that'll also be point. And we're just going to call this value. Actually set it to be an index, but it'll be value. The name will be value. And really quickly, I just want to say that whenever you're making a function, I think it's a good idea to make sure you only have one output. You can have multiple outputs, but I think it's good practice to have one, because when you eventually migrate over to coding, C++, JavaScript, Python, all of those, you can only have one output. You can't have multiple. So I think that's good practice. So what we're going to go ahead and add is we're going to break this, and we're going to take the row. We're going to add the column multiplied by row. Now really quickly, so you should have this. What is this? We need to know how many rows that there is. And you could write or add another variable, but I don't think you can set it to be a constant, which we will need it to be a constant. Yeah, you can't. So I already know what this number is. It's 10, because we have 10 columns in each row. So you could promote this to a variable, but like I said, there is no constant. So we kind of already know what it is. But you know what? For organization purposes, let's go ahead and we'll make another function. It's just going to be a return, and we're going to call it row count. We'll have an output of an integer, and we'll just call it value, and it's just going to return 10. And let's go ahead and make sure it's pure, and we'll set it to be private because nothing else needs to access it. And we'll also set it to be a constant. So compile that. Then we'll go in here and we'll go ahead and add it in. And this is basically, because we can't, like I said, because we can't have constant variables, I think this is a good idea to kind of help keep track of everything instead of just having a bunch of variables. And if you need to, for some reason, change this, you don't have to dig through all the functions to find it. So we'll close that. And really quickly, let's set this to be pure. So we'll set that to be pure. And then we'll go here into row count, and we'll duplicate it, and we'll call this column count. Everything, since we copied it, everything should be there. And we're going to default this to be 21 because there's 21. I would like to note real quickly is that we're going to add one more. The first row here is going to be empty. We're not going to use it, but it's basically to check if a block is too high, then that means it's a game over. I forgot to mention that in the setup, that there's actually 20 columns, not 21. So now that we have this, we'll go ahead and close all this out. We'll close this as well. We don't need the viewport or the construction scripts. And we'll categorize this. I'm going to just call it math. And then I'll also add all of these to math. Now we can test this really quickly. So if you pull this out and you have the array, and you use a get copy, now all we have to do is just provide a row and a column that we're looking for in order to find it. In order to find what we're looking for. So 0, 0, which is this one right here, not this one, this one. So if we go down one, it'd be 11. We're going to set up a debug tool in another video, but just trust me that this is working as long as everything is wired right. So after we've done that, let's go ahead and we'll add another function, and we'll call it can input. And what this is going to be, it's kind of a weird name, but we're going to go ahead and have this ready, and it's going to return a boolean. And what this is for input. So if we're playing an animation or there's something going on and we don't want the player to move, then we'll return false. So we'll just put value, make sure it's pure as well, and it should be private. And we'll go ahead and default that to true, and we'll make a variable, remote to variable, and we'll just say allow input. So compile and save, and we have that ready. So one more thing that we need to add is go ahead and add another function, and we'll call it place filled. And before we continue with this function, let's go ahead and go back. We'll go to the game because nothing else is going to use this but the Tetris player. So we're going to need an enumeration. So go ahead to blueprints, press enumeration. So go ahead and name it place type en for enumeration, and we're going to add a couple entries in here. We'll go ahead and add 5 entries to it: empty, taken, floor, outside grid, and out of bounds. And what empty is that if there's nothing there in the grid position that the block wants to go to, we return empty. Taken would be the opposite. Outside grid is if for some reason it's above the grid. So when we first spawn it in, it's going to be above the grid, and we want to ignore any of those negative values that we're going to use. And then outside of bounds means it's either too far to the right or too far to the left. So now with place filled, so we also need to go ahead and add the point struct that we made, and we'll call this point. So we're going to go ahead and set the output to be the enumeration that we made. So I'm going to rename it to value. That's why I'm going to name all the outputs on functions instead of return value, just value. So now before we continue, there's actually quite a few things that we need to check. So the first thing we're going to do, actually, let's go ahead and promote this to a local variable so we can keep this organized. And I always put _L at the end of any local variable, and I recommend doing that as well, not only so you can name it the same thing as the input, but just in case if you're going through the function and you want to know if a variable is local or not, you'll see the L and you'll know. So the first thing we want to check is if the column is less than 0. Is it above the top of the grid? If it is, then we just want to ignore it and just return outside of grid. Just add a return node and select outside of grid. So the next thing that we want to do is we want to get the row. We want to check and see if it's greater than 21. So if it's greater than 21, that means that it's under the floor. So go ahead and plug in another return node, and then we'll say floor. So really quickly, I made a mistake. It's actually not the row, it's actually the column. Make sure to go ahead and switch that, otherwise your game will break. So the next check we're going to do is we're going to check and see if it's out of bounds. And we're going to take, this time, we're going to take the row, and we want to check and see if it's less than 0, which means that it's gone past. This is index 0, so anything less than 0 has gone past the left side of the grid. And let's go ahead and Control C and V to copy that. And another thing is we want to check and see if it's greater than 9. And if it's greater than 9, that means that it's gone, the index here is 9, so anything above 9 also means it's out of bounds. So we'll add an OR boolean to this and plug this in to the branch. Now go ahead and clean up the nodes a little bit. So go ahead and after you've done this, so if the row is less than 0, it's out of bounds, or greater than 9, it's out of bounds, go ahead and add another return node, and we'll return out of bounds. So now the next thing we want to do is, now that we have this function, position to index, we can go ahead and just plug in the point. Let's go ahead and promote it to a local variable. So I'm going to call it found index. So the reason we want to promote this to a variable is because if we plug this in to say another function or something else, it'll run this function multiple times. So I think it's a good idea to promote it to a variable so that way it only runs once. So now what we want to do is we want to get the grid data. What we want to do is valid index, and we'll use this function, the return value of this function, and we're going to use a branch, and we're doing this just in case we pass in a really large number for some reason. If something goes wrong, we'll know right away. So on false, we're going to do a print string. So we'll go ahead and make a print string. I just named it invalid index, and I'm going to put the function name so that way I know what's calling it, and I'm going to set the color to be yellow. So now this is just if something goes wrong. Just make it return empty for right now. And now the next part is really easy. We're just going to get the grid data. We're just going to do or use a get, and we're just going to plug in the found index. So remember, we do this is valid check for safety. If it is valid, then that means there is a proper index in this array, so we can go ahead and act upon it. So we'll just add a branch, plug that in, simple enough. And then, so if it's true, that means it's taken. We're going to use true as meaning that index is filled. Add another return node, and just return taken. And then add another return node, and that one can be empty. So we got a couple functions that we have set up. So place filled, which by the way, let's set this to be pure. So we have a couple helper functions to help us out to make it a lot easier. And I'm going to go ahead and end the video here. Compile and save all if you want. And I would like to mention that I do have a Patreon that you can check out in the description. So if you would like to support me, that would be great. But this is going to do it for this part, so thank you for watching.